Welcome, everyone. Today's going to be a really different day. So this is not on the final. This is also not normally part of the class. This is just me telling you what I think you should know about being a data scientist. I have about 3 hours of slides, so we're going to go really fast. Yeah, so let's hop in. All right, so this is in 3 parts. I'm going to talk about this. The first part is really about this class. Then I'm going to talk a little bit about my ideas behind what good data science looks like and the principles behind it. And then we're going to talk about the future. All right, so now what? So you've been in this class for a while, and there are a ton of people who paid $30 to Coursera and are calling themselves data scientists. And you've been here working really hard, and some guy gave millions of dollars for a data science institute, and you're sitting there like, I do not feel like I got my money's worth, right? Like, why aren't I a data scientist? Totally fair question. So let's step back. This class covered an intro to Python, right? It covered some stuff about data and what data can look like and different ways it's represented. And then we talked a lot about inference, right? So how do you learn from that data? How do you test hypotheses, that kind of thing. The big question for this class, the overarching thing, was how do you use computers to analyze data in a way that helps people make decisions? Right? So to unpack that, really we spent sort of equal times on each of those pieces, right? How do you use a computer? That's the first one. To analyze data, right? That's the second one. And then make decisions. That's the third one. That's a lot to pack into one class. And I'm pretty proud of how well everyone's done and what we all got through. But we weren't able to cover everything. So let's talk about what we weren't able to cover. Yeah, so we weren't able to cover how to do data science, and it's actually really tough. I was looking back at the quarter, and the big miss here is I feel like you got a lot of nuts and bolts about how to do techniques and individual things, but I'm really disappointed a little bit in how much the big picture didn't come through. So today is me trying to fix that some. We're not going to be able to fix that, right? Data science is a big, messy thing, and it's going to take a while to sort out. So let's dig into that a little bit. You may have noticed in this entire class, I did something that I think most people don't do when they're teaching a data science class. On the first day, most of them stand up and try to tell you what data science is, right? They do this definition thing, and everyone feels the need to do it because nobody has any idea what it really is. So I'm not going to do it. I'm just not. I can tell you, so this is Bayes. We were talking about him the other day. A lot of people think data science is all about training models. I'm going to tell you that I think this is one way to not define data science, but to talk about what happens at work for data scientists. This lines up pretty well with my experience, for better or worse. So everybody thinks that sort of refining algorithms and mining data and doing those sort of training things is going to be the big chunk of time. Look where all the time is. The time is collecting data and cleaning and organizing data. It is all in the shoveling this stuff around and trying to get the basics done. This is getting better slowly, but for most companies, getting access to reasonably clean data that you can actually start with is where all of your time is spent. Sort of the bigger and more mature the company is in the analytics space, fine. But this is what data scientists are really doing. And it's a really different view than what I think everybody says when they say define data science, right? So what does a real data science problem look like, right? So that's the next question is, if this is what people are doing, why did we teach you all this other stuff? So here is, this is from Kirill Eremenko's book, Confident Data Skills. I use it as the textbook for DSC96, which I really like this book. It's like a paperback. It costs like 12 bucks, so you should read it. This is a process that he presents for answering data science problems, for how to tackle them. So the first thing you do is you have to find the question. The question is a really interesting one. So what I do at work is I try to get people to tell me what it is they want to know in just English, right? To figure out what the goal is. So often that will involve somebody coming in and saying, hey, why are our customers leaving, right? And then you got to start teasing that apart. When you say, why are they leaving? Do you mean it's changed over time? Who do you think the customers are, right? Like, is there a subset? Why do you think this is true? What data, The next thing you do is you have to get at the data. This is where you burn a ton of time in companies that aren't super well organized. And a lot of it is around things that we did not cover in this class that you will come to know really well in the future, and even more when you're out in the world. But completeness is a huge thing. Often you have samples of data, there was an outage one day and you're missing stuff. It's just a disaster in the real world. Fixing anomalies, there are every kind of error. When you scale up, you will see just the weirdest things. And sometimes something you think is an anomaly isn't, right? I just found out earlier this year that there are 45-minute and half-hour time zones. So ones that are not on the full hour, but they're 30 minutes off every other time zone. I thought there was a bug somewhere. It turns out it's just true. And that's part of this quality assurance thing. You just dig in on this stuff and start trying to figure out what happened. I was working with some traffic data that the San Diego Police Department collects, and there was an accident on Pomerado Road in 2016 that they report killed 245 people. I think this is not true, right? That would have made the news. The next thing you do is you got to analyze the data. So now you have a question and you have some actually clean data, and you got to mash these together somehow. This is where we spent all of the time in the class, right? And the reason we spent all the time there is because if you can't do this step, if you don't know what the limits are and like how to actually do this work, you don't know how to prepare it. You don't know what kind of questions you can answer, right? Now you know one of the questions you can answer is, what's a good line that would fit through this data? Or are these two distributions different, right? And so you could translate a question like, why are the customers leaving, into a hypothesis test. They're leaving more now than they used to be, right? And you could actually test that hypothesis. So we spent all the time on 3, and in fact, 3 is a huge world. It's really cool. There's a ton of stuff in there. Statistics is awesome. Machine learning is great. The next step, usually you want to look at your results. We did a little bit of this. We did some scatter plots and some histograms and things like that. This is a huge area. I'll talk about it a little bit later in the talk. I am hoping we get an upper division elective exclusively devoted to data visualizations. I think it's super important. And then the last one, which seems like the same thing, is to present your findings. This includes documentation, user interface stuff, turning something into a product could be in here, so like actually shipping it and getting it out in the world. A lot of data science projects fail to do these last steps. Somebody does some cool analysis on a laptop, and then they put the laptop away, and the whole thing is a waste of time, right? So you need to sort of keep going with that. Somebody today told me that people aren't really stupid. It's that things are really hard, and so you should just like do your best to pull them along with you, right? That's really this last step, is convincing other people you've done something valuable. All right, so we spent all our time in the middle, and for really good reasons. It's because that's the core of this whole process. But it's the core, it's not the whole process. These other steps are equally important. I spend almost all of my time not in step 3. Maybe I do more of that than usual, and it's maybe 20%, right? All right, so that's what data science, I'm not going to define it, but that's what I do all day, and that's what most of the people who have the job title data scientist actually do, is this stuff and the stuff on the previous slide. There were also a bunch of other topics that I was not able to get to as much as I wanted in this class, and an important one is the ethics of data science. There will be an upper division elective on this one. There's also some really cool books coming out, and all of the Democratic presidential candidates who have announced so far have had some pretty bold things to say about data privacy and artificial intelligence, and it's going to affect your lives. This is a really hot topic right now. A couple of folks, DJ Patil was the, unfortunately, the only chief data scientist of the United States after he was no longer had that position when the administration changed. We didn't get a new one, but we had one for a while. He ran data.gov, which is awesome. And then Hillary Mason's also, she's super cool. She's got a great Twitter. I don't know Mike. They wrote a book together. It's this free ebook. You can also buy a printed copy if you feel like it. But it's on GitHub, and they describe this really nice thing, I think. The core of their idea is that data is this incredible lever arm for change, right? You have this big impact thing that's happening, and we need to make sure that that change is the one that everyone wants to see, that supports all of us, right? And that has not been consistently happening. And I think you can probably think of a lot of examples that have come up in the news where that fails to happen. One thing that's being thrown around a lot is to have an oath, like a Hippocratic oath for data scientists, one where you say you're not going to do bad things. They actually strongly disagree with that, and their disagreement is rooted in research. The way to do this is not a one-time, like, promise you're going to be good or else. It's a checklist, and this is the checklist. So every time you ship a data science project in the world, they recommend adding this as one of the checks before you put it out there. And I'm adopting this at work. One of them is consent. So the question is, are the people who are interacting with this thing, did they agree to interact with it, right? Do they really, did you ask for permission? The second one is clarity. Are you telling them what they're signing up for, right? Because you can't really, informed consent is what you want. Just consent doesn't do it. Consistency and trust is a big one, and that comes down to a lot of different things, but one of them is not sort of violating people's expectations around, say, privacy or whatever. So when you go and you get someone using a product and then suddenly you change all the rules on them, even if they clicked OK, that doesn't mean they really were happy with what happened. Data control and transparency is going to be a huge issue coming up. For those who don't know, Europe passed a big law recently called GDPR. It's the European Union's privacy laws. It had a huge impact on the way that web companies and data companies work. It is still causing massive shifts to happen. California's similar law is coming into effect. I would not be surprised if we see movements to have a federal one here soon. You need to be aware of these if you are collecting anything that is remotely personally identifiable information. There are serious penalties for companies that don't do this right. Also, it's just wrong to lose people's data. And the consequences, it's good to think about, like, what if this goes badly, right? What would happen? What are possible things? And to actually sit down and say, what harm could this cause and how could we mitigate it, right? When you put all this together, you can think of a lot of different examples where this has gone wrong. I'm just going to show one that this is the kind of thing that early machine learning can do. This is the cause of a lot of different problems coming together. So one problem was they did not test this feature on a diverse enough set of people. One of them is they didn't think through the possible harms that this could cause, right? But when you release this kind of thing into the world, you can really do some messed up stuff. This is a pretty minor offering. It gets dramatically worse. There's a book that I really strongly recommend on this called Weapons of Math Destruction by Cathy O'Neill. And it's this thing about how big data increases inequalities that are happening in the world and really fundamentally can threaten democracy. It's really interesting reading. I think some of it is, she's really much more thoughtful than most people who write about sort of artificial intelligence is going to take all our jobs articles. She really knows what she's talking about. We don't always agree on everything, but I always find her thoughtful. Whew, that was ethics. All right, we're moving real fast today. Next up is visualization. So that's another topic we did not get to cover in this class as much as I wanted to, and I really wish we could have. This is a plot. There's this group that does these monthly plot makeovers, and this was the before plot. So I think it's saying something about gender gap in fields of study, right? But it's kind of hard to tell what's going on. And so, like, if I were to ask you, what field has the largest gap? It's going to take you a minute looking at this to figure it out, right? And then what if I said, what about as a percentage of the women in the field? Like, which one would have the largest gap? Like a relative gap, not an absolute gap. Now you got to like do a bunch of math in your head and look back and forth. So they reworked this plot and turned it into this. The font's a little small, but to me, it is just dramatically easier to tell what's going on, right? You can tell when things are reversed. So like education is clearly, some of these fields have more women, some have more men, some are equal. You can get a good sense of the gap and the overall numbers. So these kind of subtle changes can make huge differences in interpretation. There's a whole field about this. Again, there's a book I recommend. This one I would get from the library because it's like stupid expensive because it's all color plates and stuff. But the visual display of quantitative information is a really good read. That March to Russia plot that we looked at earlier is talked about a lot in that one. But it's worth doing. I think the takeaway for visualization, and we'll talk about this a little bit more later, is really this stuff's hard, right? And communicating it cleanly is hard, and having somebody who thinks carefully about that is important, or people will be misled. All right, another thing, I was going to lump this in with, whoa, what did I do? I was going to lump this in with ethics, but actually it's a little bit different, right? So this is the privacy question. Privacy is sort of an interesting thing. There's a couple of places this goes really wrong. One is if you knew how much you were being tracked, you would be horrified. I think most of you are probably not aware, but there are many advertisers know where you are all the time. It is startling when you start digging into this, how much data you can own. I haven't been on Facebook in about 5 years, and my grandma got a new phone. She asked me to sign up. And so I'm like, okay, I get a brand new email address I've never used anywhere, use it on a brand new Chromebook, right? I sign up. They ask me for my phone number. So I give them my phone number, they send me a text, we're all good. I log on, it lists 150 people that know me, right? That's terrifying. Like, what did it do? Well, it turns out those people had my phone number in their phone books, and they gave their entire phone book over to Facebook, right? And so Facebook can just look up my phone number in other people's phones and figure out who knows me. And then it can do social connections between them and figure everything out. This stuff's just everywhere. Two things I want to show you if you haven't seen them before. I love these ones. Oh God, where's my mouse? So just show of hands, who's seen this site before? Okay. So this is kind of fun. Let's see if I can do this. All right, so what I'm going to do here is type in my actual personal email address. And it's going to look it up, and it's going to say, oh, good, you were in these following data leaks. So Dailymotion, Discus, Kickstarter, Ticketfly, all of these companies had my information, and then it ended up on the black market somewhere. They got hacked. They left it in an unsecured thing. I was surprised how many of these there are, and they just keep happening, right? So that is, the thing I want you to take away from this is not just that these horrifying hacks happen all the time, but that you should treat data sort of like toxic waste. If you don't have a good reason to be holding on to it and storing it and like mining things out of it, think very carefully about just keeping it around, because it can cause your company to be on this list, and that will destroy a ton of value for you and the world. It is bad, right? This stuff causes harm, and you should think, maybe we don't need to gather all that data. Maybe you do, but maybe you should be very careful about it, right? Start with a culture of security. Cool. This other one, this is, I'm just going to throw this out there. This is terrifying to do live for me. So I have had an Android phone for a very long time. It tracks me in ways I just recently found out about. So this is a map of everywhere I've been since, let's say in the last like 6 years. And it's actually much worse than you can imagine. If I zoom in on a certain day, so let's say, where was I last Monday? You can see that I was at home, I drove to work, it looks like I went to lunch here, I came down to teach. It has this detail for 6 years. The reason this makes me nervous doing it live is I don't know that I want you all to know where I've been every day, but Google knows, right? And who knows who Google tells? Anyway, so you can go to this site if you have a Google account and an Android phone and have location tracking turned on and be surprised. So again, the point of this is there's a ton of data out there. You need to be careful with it, and privacy is an increasing thing. So welcome to data science. Okay, that was a bunch. I am going to shift gears to part 2 now. So part 1 was really about the stuff that I wanted to put in DSC10 that didn't fit because we had to do the fundamentals. The next step is really about how I think about data science. I'm going to go through this kind of quickly. I've written about it a fair amount. This gets sort of big picture, well, we'll just see how it goes. Oh my God. So big picture, top view, my approach to data science involves these 4 things. So honesty, curiosity, impact, and humility. And we're going to go into a lot of detail on that and treat them as sort of the categories. So honesty for me means a couple of different things. One is honesty with the people that you work with, the people you collaborate with. What this means in practice is that I think one of the best things we can do is openly and honestly review each other's work, meaning that you give feedback to people in a direct way, and when people give feedback to you, you do your best to listen to it. This stuff is very, very difficult. I am wrong almost all of the time, and the only way I get better at this is when people tell me when I'm wrong, right? Exercising independent judgment on this is critical. If I have an employee and they're not willing to say, oh God, that doesn't make any sense, we could end up doing something bad, right? It's important, because this stuff is so hard, to be really open with each other. It's also important to be open with yourself, right? So again, I'm wrong a lot, and so are you. We all are wrong a lot. Acknowledging that you don't know things is good, right? Shipping things into the world that you don't understand or you don't know what they do or whatever, that can be really bad. Think about all those security mistakes that happened. A lot of those are because people were like, well, I read an article, it's probably good, right? Really understand what's going on before you do things that can cause big effects. And then this one, I think, is especially true for a lot of people in computer science and things in STEM fields. We often forget to acknowledge the things we did well, right? So when you're honest with yourself about the failures and the ignorance, you also got to own the successes. I got a guy that graduated from here last year, and he's working for me now. And today he said, "Oh, I'm really happy we figured this out this week." I'm like, "We? Dude, I still don't know how it works. That was all you. Like, own it. Say that you did it, right?" I think that's a really important thing. And finally, the group that you have to be honest with is users. My take on this is a little bit different because instead of dealing with consumers through like mobile apps or whatever, I deal with business users. So the constraints are a little bit different. But I think this holds in general that anytime you're misleading a user, they're going to make bad decisions, right? You're nudging them in the wrong direction. And so to avoid that, you should not tell people things that are not true. It turns out that's harder than you'd think. So one thing is, don't ship stuff that's bad, right? But when you do, and you will, you're going to make mistakes, you should acknowledge it quickly. You should fix it. There is a process for how to acknowledge, apologize, review, and fix these things so that they're less likely to happen again. I really recommend sort of looking things like that up and having a formalized process when you're out in the world for like, look, we're all going to screw up. But you really need to own it. You need to empathize with the other person, and you need to see how you can make it right. And then you need to figure out what happened and not do it again. Saying that something will never happen again, if you're not sure, it's just lying to them again, right? You're back at the top. That's no good. Finally, I think it's really important to check in with anybody you're showing your analysis results to see if they actually understand what's happening, right? A lot of times you think you might be giving some results to somebody and it clearly shows that there's a problem, and they'll look at it and say, "Oh, so we're good," right? You need to actually make sure that you're making that connection. All right, that was honesty. Step 2 was curiosity. Curiosity about data is one of my favorite ones. So you really need to understand your data, really dig into it, and by that I don't mean understand the average and the standard deviation, but understanding what it means in the real world, right? So every now and then I'll see somebody who turns in an assignment and their estimated age is -12, and you're like, come on, you know how age works, right? Age is not a negative number. Or people who weigh, 6,000 pounds, right? Like, you made a mistake, you can fix this. But more deeply, when you start doing any sort of machine learning or prediction, you need to really understand, like, how does this interact with the real world? Does this make sense? Like, in actual world, not does it have a good score? I think this is true, this bottom one here, that really understanding what's going on and getting a real handle on the data almost always beats the good algorithm. I think this is one of the biggest damage that a lot of the focus on like big machine learning stuff has happened lately, where everybody wants to like make improvements there. Look, that stuff's super cool. But oftentimes, if you reframe the question a little bit and pull in a little bit of different information, you can do way better than if you sit there just tuning forever. When something's wrong, you actually have to figure out what's wrong. Hiding it and pretending it's not there, or just saying like, oh, we'll remove all that data. If you don't find the root cause, you're not going to get things better. All right, this one's related. This one's curiosity for using science. You all pretty much should have this down by now, but this hypothesis, test, measure thing is really key. And I think the biggest thing I got out of grad school, honestly, and the biggest thing that I worry that you are not going to get in an undergrad data science program is this idea that you should be able to change your mind about strongly held beliefs with evidence. Right? Part of grad school, part of getting a PhD is getting things wrong over and over again because you're trying to add to human knowledge, and it turns out that's hard, right? And so you keep getting wrong answers. And so you often think, like, you have to every day wake up and think, I think I'm gonna, try this thing and it's gonna work. And then you're like, well, no. But if you keep thinking it's gonna work despite evidence, you will waste so much time. So I really hope that we can fit this into the curriculum, but I encourage you to do it. The final part here for curiosity is self-improvement, right? And I could go over all of this, but this is the key, right? Your ability to do good work is the thing holding you back. Like, no joke. You have access to all the data you could want here at UCSD. You have a laptop, you can get cloud credits. Like, there is nothing holding you back from doing world-class work other than you are not good enough. And the way you get better is by learning, right? This was another terrifying lesson of graduate school for me, but I realized at one point that I had all the resources I could want. I had the best libraries and mentors and all the rest, and really it just came down to like me and a laptop and figuring things out about the world. That's terrifying, right? But it's also really freeing. You have what you need to make this happen. Learn faster. All right. So that was honesty and creativity. Next up is impact. Impact. Okay, this is really it on impact. Impact is really about doing work that matters, doing work that something happens. Data science is having this real problem right now where it is not actually finishing the job of making people change what they do. So a lot of times they'll do this cool thing where they say, oh yeah, we made a prediction and it's helping people, or something. The places where data science does really big things is when you can show a plot or a summary or something to someone, and then they say, oh, I was going to do this thing, and now I'm going to do that thing as a result. You have caused an actual person to do something different based on data. That's like the best thing a scientist can do, right? That's the dream. So if you are not causing people to change what they're doing, you are not having an impact on like real things. You're just moving data around, which is super fun. Unfortunately, that's not all there is to impact, right? So how do you actually do that? One of the things is getting unstuck. A lot of being a data scientist or a scientist in general is being stuck. And so there's some keys to this. I'm gonna let you look at these. A personal favorite of mine is Brian Eno made this. The musician has this deck of cards, and they have these like odd suggestions on them. And I will, like, no joke, look at these things and use them as like a getting unstuck thing. But radically different approaches. Often I will end up in this situation where I get stuck in a local maximum, right? So instead of finding the globally best solution, I will find some solution that does a little bit of the right thing, and then I'll keep trying to make it a little better, instead of realizing that if I did something else entirely, I could be 10 times or 100 times better, right? That's hard. The other thing you can do to make an impact faster is to just do what other people have done so that you don't have to invent this stuff, right? So almost no one I know is inventing new stuff on a regular basis. What we're doing is taking other stuff people have done and slapping them together into new configurations or applying them to new problems. That's really hard too, but like, I don't do research where I'm like making up new methods for doing machine learning. I'm just trying to get the stuff to work. And so the more I can steal from other people, as long as it's open source, steal, I don't mean steal, but like take their ideas that they've published and apply them. I don't have to do that research. That's awesome. Fast following other people is totally acceptable, and you should do it. All right, so that was honesty, creativity, impact, and humility. I think I've talked a little bit about this, but we're wrong a lot, right? Most of us, when it comes down to things, are a little bit wrong pretty much all the time, and really wrong pretty often. So how do you do this? Well, so one thing is to make sure you check things, but I think a bigger thing is to check if you're wrong, right? Talked a little bit about that with sort of big numbers and sort of crazy numbers and things, but often if you have an idea, instead of going out and finding ways to support that idea, you can do sort of a proof by contradiction thing and see if you can find evidence that is not true. As soon as you found that, you're done. You don't have to keep searching. The idea is bad, right? Invalidating things faster feels weird, but it lets you do a lot more. Edge cases is this concept that a lot of times things are true in the center of the distribution, but when you get out into the weird areas, things fall apart. And so you should always make sure to check sort of extreme values to make sure things make sense out at the edges of your prediction ranges or whatever you're doing. Not being fooled by randomness, oh my God. So we've spent a lot of time on that in this class. This is the hardest thing ever. I'm going to tell you most of the stock market is people being fooled by randomness. All the people on TV talking about the stock market are just making things up. Like nobody knows what's going on there. And if they did, they would not tell you. They would just take tons of money from you, right? So this is actually a way bigger part of society than we think it is. And not doing that is super hard. So that's all I'm going to leave you with on that one is good luck. Another part of humility is stop doing hard things, right? So this is sort of a theme in here, but if you start with really easy things, the minimum viable thing you can do, the smallest piece, and the simplest method, you can move faster, you can test more things, you can fail more quickly, you can learn from your mistakes, you are less likely to make mistakes. The other thing is that if you end up doing hard things, there's this weight that comes with that, right? So if you develop some hard thing and then later you want to go back and add to it, it's way harder, right? It's got like lots of moving pieces and it's hard to maintain, it's hard to document, it costs more in computation time, right? Don't do hard things. This stuff's hard enough, like do the easy thing. And then, boy, this talk's an upper. Most of your work's gonna fail. Like honestly, if you're doing data science work, a ton of it is not going to have the outcome you want. Most of the work I do does not make it into the real world. Customers never see it. And when you acknowledge that, it actually frees you up a lot. So you can plan for most of your stuff to fail. That's super cool. Now you can do things in like a throwaway way. You can do rough drafts, right? Think of it as a writer. If most of your stuff's not gonna get published, you can just start writing whatever you want. Like just really crank on it fast. You also can just plan to throw most of it away. Maybe document it so that you don't do it again in 6 months, which I do find myself doing sometimes. But you also should try to prove that you're doing bad things quickly, and so identify them, and also not be sad about it. I often, when I fail to do things, it's tough because I did a bunch of work on it, but the faster I can let that go and do the next thing, the more productive and happy I am. So I think just acknowledge that a lot of your stuff's gonna fail in the real world, and it's okay. And that's just how it is. You gotta just keep rolling. All right. That was my principal data science. I got like a little bit of time left, so I'm gonna talk about the future. I've already told you several times that I'm wrong most of the time, so you should not listen to me, right? But I gotta do this because it's the last class. So a lot of you are going to take DSC10. DSC10 is hard. It is a big step up in coding challenge. I have talked to a bunch of students that were moderate coders, and they had a really hard time. I just want to be real with you about that. I think all of you can do it. If you made it through this class, you can, right? It is not conceptually more challenging or anything. It just, I think this cartoon nails it. Like that's what learning to code is. It feels like that a lot. It still feels like that to me. There are some links in the course webpage for a couple of resources to practice general coding skills. But I would really recommend, if you have some time over spring break and you're going to be taking 20 just coming up next, maybe crank through some tutorials and see if you can up your Python game a little bit before you launch into 20. If you really feel marginal on it, taking a quarter off and doing some stuff on your own or whatever would be totally fine. I think we're going to have spots in DSC96, which is I'm teaching next quarter. Normally it's only open to folks that are concurrently in 10, but it looks like it's not going to fill with that, and so we may open it up to folks that have previously taken 10. So if you want to take some time off and do a for fun 2-credit pass no pass class, I love that class, and I'd love to see you in there. All right, what about after DSC20? Well, someday you're going to have to get a job, right? And I know a lot of you are thinking about internships and things. This is my advice on how to get a job. This is probably something you don't see a lot in college, but because I have a job, I like talking about what it's like out there. So these are the 4 parts I'm going to go through. Okay. I made this slide because these are skills I have learned over the years. Some of them I use, most of them are garbage. I would never recommend using them. Some of it is deeply embarrassing that I spent that many years using. Some are great. Don't get too attached. I mostly like blue things, it turns out, when I was making this. Like, I have better feelings about the blue ones, so maybe that'd be good. But not all of them, right? Like, oh my God, this one just about took down a startup I was in. Anyway, a lot of you though, when you're looking at jobs, you're like, oh, I see all these listings and they list a bunch of tools and I don't know all those tools, so I should learn all those tools. Don't do it. Here's what you should do instead. You should learn concepts, right? When you have a thing you don't know how to do, you should figure out what that area is called, and then you should learn one tool in that space. These tools are this is a big disclaimer, my current recommendation at what I think is the most fun or like the cutting edge one or whatever, but reasonable people disagree on this. Don't go learning this stuff because I said so. Like, poke around and figure it out. One thing that you should do is querying, right? So that is what we've been using the data science module for, these sort of joins and aggregations and things. There are other great tools. So Pandas is kind of a querying tool. Spark gets used a lot. SQL is one of the core things. I think most of you could probably teach yourself SQL in a weekend. It is not, you're not going to get great at it. But if you picked up Python, it's like, it's not really a full coding language, it's a query language. You just say like, select some columns from a table and stuff like that. It's not trivial, and being good at it is hard. But to get as good as I am probably would take you 2 days. Web visualization. If you want to make live stuff on the internet, there's a ton of ways to do it. It seems like D3, it's a JavaScript library that lets you make super cool interactive plots. It's a lot of what, like, when you see things on 538 or New York Times or whatever, that are those really rad reactive data visualizations. A lot of them are made in D3. I don't use it because I hate JavaScript, but I love it when other people do it with my data because it looks really good. But you should learn some way to put your data on the internet, right? So that'd be good. The cloud. You should learn the cloud. It turns out the cloud is just other people's computers, but they give you services so that instead of like having to manage all this stuff, you can just have like storage and compute and things, and it's all abstracted. You can get free credits when you're a student. You can just like sign up and say like, I want to use your cloud, and they'll just like give you a login, and you can just start burning through hundreds of dollars as long as you promise not to mine Bitcoin or whatever. So like, you can just do that. AWS, Amazon Web Services, is the clear leader right now. I don't actually use it, but if you're going to start somewhere, probably start there. Google is fine. Microsoft's fine. Don't choose anyone else. Data exploration. There's all these tools for doing data exploration. I like Tableau. I don't use it at work that often anymore, but it's free when you're a student, and it's a good one to know. that lets you sort of throw variables around real fast and understand what's going on. You will learn GitHub, but you need a way to collaborate. And then this is the punchline. Anything weird, like let's say you want to pull a bunch of tweets off the internet and then like see if they are happy or sad tweets. There's like weird Python packages built for everything. So here's what you do. You just literally Google Python and then like make images black and white into Google and it'll take you to the thing. And then what you do is you look at the repository and you check two things. Is it pip installable or does it require you to do like weird compiling of binaries? If it's weird stuff, don't do it. And then the second thing is, has it been updated in the last 3 months, year, something like that? You don't want abandoned stuff. Abandoned stuff won't work with modern code. It's got security problems. It's a mess. And sometimes you'll find like really old stuff kicking around because Python's been around a while. Anyway. All right, what else we got? A bunch of you want to do projects, right? Or like start doing data science. Do it. That's the #1 way to get started is by getting started, right? The next thing is you should just take someone else's stuff and then do it yourself. So literally you should find a project you like and just like rip it away from them and then start tinkering with it. If it's public on the internet, don't break laws, right? But a lot of stuff's open source. You can just find some Cogs9 project that looks cool and then just start modifying it and understanding how it works. The license is there. You're allowed to do that. That lets you get started really fast. And then you start building what you want to see. And the reason you build what you want to see is because then you stay motivated. You stay on top of it. If you try to do stuff other people want to see, you will hate it and you will give up. You have to be able to like wake up in the middle of the night and be like, oh, that's the thing I want to do is that fun project. And then the ultimate secret is doing good work and sharing it with people. The way that you get better at this is by doing bad work and showing it to people, and then they tell you what's going on. But you need to actually get it off your laptop and out into the world, and people will start giving you feedback. And I stole this from a book called Steal Like an Artist. So, okay, I got like a couple of seconds left. Ira Glass is a radio host, and he has this sort of short speech he gave at one point, and I adore it, and I was planning on reading the whole quote to you, but we're short. The gist of it is, there's this gap that happens when you're starting in something, and it's the gap between what you know is possible and what you can do today. And I think a lot of people in data science are like, oh, data scientists do rad stuff, and then you look at what you can do at the end of class, and you're like, I can't do that. The way you do that is by just doing bad stuff for a long time and getting feedback. But you just got to push through. Like, it just stinks. And the volume of work that you do and the continuous self-improvement is how you do it. Every time I look at a project I did a year ago, for 20 years now, I've been embarrassed by how bad it was. Every year I do get better at this stuff, and you just keep cranking at it. All right, this was the how to get a job part. I'm going to go fast. You need a portfolio, right? So you should have an online presence. If any of you don't have this stuff, you should do it. You should have a GitHub. That's where you put your code. You should have some sort of professional social network that is different than your personal one. For the love of God, keep them separate. I have 2 Twitter accounts. I will tell you one of them. Medium seems to be where a lot of data scientists are writing longer form pieces. LinkedIn is for, there's actually a lot of people there, but it seems to be older, more conservative stuff. I actually really recommend a personal site if you're in the job market, but you can also do a portfolio somewhere else. This is a site of Scott Cole. He's a PhD student, and I showed it because, it's got all the normal stuff, but then I was talking to him about a job, and I saw this like burritos link, and immediately you're like, okay, I'll click the burritos link. He collected a bunch of data with his friends about burritos in San Diego and made a web visualization, and you can go through and be like, oh, I only want cheap burritos, and they've got to be vegetarian, right? And you're like, Like, what a cool thing to put in the world. And immediately, like, I just want to talk to this guy, right? Data science projects don't have to be big and crazy and exciting. They just have to be, you should have a presence that does this on the internet.